Hello and welcome to this episode of Conscious Design. I'm your host, Ian Peterman, and author of the Conscious Design book. And today I'm excited to have David Hertz. He's an architect, founder of SEA. He's worked with SkySource, with XPRIZE. He also has Resilience Fund and foundations around sustainability and investments. Welcome to the show.
Thank you. Happy to be here.
So you do a lot of things, but everybody loves a good origin story. So let's wheel back time a little bit. What got you into architecture and sustainability?
Yeah, it's an interesting question because I started off really as an environmentalist, mainly just because I had a lot of connection to nature. I grew up really fortunate as a kid to grow up in Malibu, and one of the things to do in Malibu is to surf and to hike. It's a very long city that's bordered by ocean and mountains. So I grew up very much in contact with nature, but I also really loved to build things and design things, and grew up in an artistic household. And so at some point I had to rationalize my place in the world as being part of the built environment, and how do I square that with its impact, its known impact on the natural environment.
And so from that, right, you went into architecture and you run your own architecture group. Let's talk a little bit about some of the projects. You have a lot of really interesting projects, quite a few focused around sustainability. What was, honestly, one of your early bigger projects that really got you, right? Because you get into anything. What was something that you worked on and you said, I'm doing it and I really love it and I want to just keep going into the many more projects you've had?
Sure. Every new project is your favorite project, and and then it just leads to another one, right? I mean, I think so. It was an incremental process. Being in architecture school was, very, very challenging, but also very rewarding, and kind of learn to work all night and work hard. And I had a great opportunity to intern with an architect named John Lautner, who has worked with Frank Lloyd Wright as one of his, disciples, and was really a visionary, iconoclastic LA architect. And that was very formative in the framework of organic architecture that Wright espoused, and a kind of uniquely American architecture. And then I worked for Frank Gehry, who, really blurred the definitions between art and architecture. And being in Venice for many years, I worked a lot with different artists as well. So the art of architecture. And then actually, interestingly, I had done a lot of work in construction early on, and I found a fascination with concrete as a material. So my actually early work evolved from construction and concrete, and a lot of the houses that John Lautner built were concrete. As a young architect, also kind of coming out of school after the oil embargo energy crisis of the 70s, was very much aware of our dependence on foreign oil and very interested in alternative energy systems and the impacts that buildings have, and the whole process of what we take, make, and waste as part of our whole kind of ecosystem of building. I started to experiment with concrete, and I started to build concrete furniture in the early 80s. That was a pretty radical idea. And I started to do commissions for public sculpture and private commissions that were all like little mini architectural projects. They involve construction, fabrication, design. And, I think when anyone dedicates themselves to kind of one practice over and over, they're learning a lot about themselves in the process, but also learning about a material. I felt limited with the weight of the material, and ultimately invented a advanced cement-based composite called Syndicrete that was in the early 80s. And I started to do precast concrete surfaces, high-end surfaces like kitchen counters and sinks and bathtubs and tiles, and that led to panels and accessories and, a lot of different things. And I actually ran that company reluctantly, because I never really started off as a company. I was interested in finding a material that didn't exist in the marketplace. And I liked the humility of concrete versus, marbles and granites and the synthetic materials. And so I was very interested in concrete, and I sold that company after 20 years to a large public company. But what was interesting about it was all comprised of recycled materials. I lowered the embodied energy of concrete by displacing cement with fly ash and post-consumer carpet fiber to reinforce it. And then I use materials extracted from the waste stream as decorative aggregates, everything from broken bottle glass to computer parts, garment kind of waste like buttons and closures and zippers. And for a record store, record corporate office, I did all discontinued records, cassettes, and VCRs and broke them up with nonprofit groups like inner city gang intervention programs. So there was a really interesting integration in the way in which Syndicrete was a kind of a global gumbo of materials extracted from the waste stream that didn't have a recycled value, but had a very interesting aesthetic value. It was like a terrazzo, a contemporary terrazzo out of society's waste. And I began to be very fascinated about what we waste and how for every truckload of goods that we order, 32 truckloads on average of waste are made. So, we have a very technical system. And so I was interested in how we think about repurposing. And that of course, led to some early interest in radical reuse and repurposing and recycling. But all of my work at SEA, which stands for the Studio of Environmental Architecture, has been about innovations within sustainability, both in the way that the buildings are built, but also how they're kind of operated and maintained.
It's such an interesting concept. You mentioned it really briefly, the cosmetic value, right? We oftentimes focus on, can we, if we recycle something, can we turn it into raw material and, can we extract gold out of it and use it somewhere else? But there is a value, and I'm glad you mentioned it because it's not really thought about very much as well. Yeah, it may not work, but like people hang records up on their wall, right? There's aesthetic value to something that may not, even if it's broken, right? It can't work how it originally was supposed to. It has, there's other ways to value something rather than just how much gold is in it. Can you melt the plastic down and reuse it? There's another layer to that. I feel like it gets overlooked most of the time. I love that concept of how can you extract value, not just in a technical way, but cosmetic, aesthetic way.
Mm-hmm. Where ideally it's not something that's hidden. It's the progenitor of the building's form. So one of the best examples of that is my 747 wing house. It's about radical reuse and repurposing, but it's absolutely a design determinant that to convince my client to buy a used 747 to cut the wings off and then turn it into a house, it was certainly about radical reuse, but it was also about making a really sublime architecture that is very aerodynamic and thin and works with the ridge line. And, when you're upcycling something like an airplane is a good example. I mean, it only has a certain amount of service life, and then there are thousands of them just desiccating in the desert, obsolescence. And they're then downcycled into a beer can again, just melted down into a beer can. So you're taking an airplane, which is, technical achievement of form and the efficiency and strength of materials, and devaluing it to a beer can, which, once it's devalued to a beer can, then it's just diluted. So upcycling and reuse, it short circuits. Like when you're making aluminum, which is a very energy intensive material, you start with clear cutting rainforests in South America to mine bauxite. And then you take that bauxite and transport it about 3 times around the world through smelting and then, operating. So there's this huge amount of energy involved in extraction of raw materials and a whole series of cascade of negative consequences. And so if you bypass all of that, then you are saving a tremendous amount of energy. And, I couldn't build a roof that had the efficiency and the structural strength and the lightweight materials that a wing has already. So that's a pretty good visual example of what I think how design is formed by the idea of repurposing.
Yeah, it's right. You're looking at things not just as how can I extract the material. It's if I want a really strong roof, what are the things out there that are already really strong that I can just use rather than trying to create, we can do it with trusses and right, we can do it. But I love that idea of, well, what's already out there. I'm really curious, how long did it take you to convince that owner to buy a wing and go for making a house out of a wing? I don't think anybody has tried that before your project. And maybe
no. A few subsequent that they've just basically reused airplanes, which are cool, but it's an airplane that somebody's living in, not like cutting it up and making a sculpture out of it. Because this house was made out of the two wings of 747 and the two horizontal tail stabilizers, and that's the wing house. And then since we bought the entire plane, actually I have under construction now for the same client a fuselage building that's like Quonset hut section of the fuselage. So it didn't take very long to convince the client. That was probably the easy part. To her credit, I mean, I modeled it, I proposed the idea. She said, let's go look at these wings because you never really get under them and see the scale. And she loved the idea. And it actually was more convincing the 18, municipal authorities in the hills of Malibu of what about it. And that included Homeland Security when they came to visit me after, making a lot of inquiries about the structural properties of a Boeing 747 after 9/11. So they wanted that we were not a terrorist cell. It included the FAA, so it's mapped, so it's not it doesn't look like a crash if, a pilot is flying over it. And it included obviously a lot of building agencies, the Coastal Commission. So, but that's part of the process. I think that's actually part of the challenge of doing anything. It's one thing that you could have an idea, you can make a rendering, but to actually implement it and to go through the system, kind of a rational system, and still get something that's fairly radical out the other end, that's a system that is inherently risk adverse, is the challenge.
You mentioned making sure that it's marked with the FAA as not a downed aircraft, which I would not have thought of, but it makes perfect. As soon as you said it, I was like, oh yeah, it's a massive Boeing 747 wing just sitting there.
Right.
Of course it would look like a crashed plane that you would call in if you're a pilot.
Right.
It shouldn't be there on the ground in the neighborhood.
It's a requirement of aviation that if you were ever to see anything that looked like that, you're required to report it. So that's why it has to be mapped.
Yeah, I mean, that's things you just don't even think about, right? You just get into it and you're like, let's do this. And then somebody says, hey, you gotta make sure nobody thinks it's a downed airplane.
Right. Or the transport, just what is it really like to cut up a 747? We closed 5 freeways in Los Angeles. They got it to a local airport, Camarillo Airport, cut the wing in half and used a Sikorsky Sky Crane helicopter to transport it to the site. So that was a kind of a large burst of carbon, one would say, but it was a short burst of carbon. That's the difference, is that this is a very remote site. And the way that we build buildings today, we tend to make them of lots of little pieces that require lots of transport, and none of those pieces really fit. So then you end up with like 30% of them is in construction and demolition waste, and they're hauled back out. And it's a very inefficient way to build. This I refer to as a large less strategy. These large pieces are transported in a very short period of time, And yes, there's a burst of carbon. We actually calculated it. We saved tremendous amounts of carbon by one, repurposing, two, creating something that was very large with very few materials. So the embodied energy of the transport was a fraction of what it would be had it been a normal house.
That's interesting. So it was overall your carbon footprint for that, even though, right, you think of like a Sikorsky helicopter, those are not small. Those are right. That feels like a lot of energy and carbon output. That's actually less because it's recycled material, and you're not, as you said, you're not wasting bringing materials in, chopping it up, and sending a bunch of it back. It's actually cheaper carbon wise to do that.
Right. Yeah, it was cheaper carbon wise, and it was cheaper than conventional building to get a roof like that. Because again, the airplane was not very expensive. It was about $35,000 to buy an entire 747.
That was the whole frame for.
Yeah. Then obviously we had labor and cutting and transporting it, but still, when compared, and the client did have it compared to trying to build it conventionally, and it was a fraction of the cost of trying to build something that looked like a wing out of steel and wood and aluminum or whatever. The wing is an incredibly strong structure. Of course, the gas tanks, it carries about 300,000 pounds of jet fuel, and it's supporting 500 people. And it's an incredibly strong and light structure. It was actually incredibly lightweight. The whole building is a fraction of the weight. That's part of, if you analyze a building, the lighter the building is, the less materials it has and the less embodied energy it has.
Right. So you were able to actually build less. You didn't need as much structure to hold that. If you had done that out of steel and wood, you wouldn't need to built up foundation and structural components more to be able to even hold that roof.
Correct.
I think we talk about that project a lot. That is just such a cool thing. But kind of moving to other areas, right? This is one area that's improving sustainability. I believe you've worked with some green roofs, solar. What are the technologies and things that when you're looking at a project, what are some of the other things that you look for to integrate that you use to make a site building more sustainable, more eco-friendly?
Yeah, I think there's a kind of a holistic approach that starts with really understanding the site, looking at what nature affords you at the site, right? I mean, depending on your climate. So it's bioclimatic, it's hyper-local, and kind of understanding its context. What is the path of travel of the sun? How much of free energy is there? How much natural air conditioning is there in terms of prevailing breeze patterns? Where are there shadows? Where is there, nature that can do the work? And starting there is the first step, and then augmenting that for comfort, but rather than just saying, well, this building could be anywhere and it's not site specific, and I'm just going to, use a ton of energy to heat it or cool it. I don't care. All sides of the building look the same. They're not really responsive to the sun, so those are the primary forms. I mean, trying to minimize site disturbance as much as possible. So not just, cutting a hill to make a big flat site, to working kind of more with the topography, and then looking further from the site, what materials, like if we are going to dig foundation, is there rock that we could use from the site? Is there wood we could use from the site? Then what other resources are there as close to the site as possible? Because the closer that you can source materials, then the lower the energy is to get them there. Except for, projects like I did one project on a remote island, and everything is coming by boat. So then it was a question of how do we make something, as efficient as possible that can fit in a container. and not have a lot of wasted space, and be very strong. And that project was interesting because it was all made out of custom aluminum extruded structures that I designed and built and engineered, and a giant folded tensile roof membrane, so that whole roof, which is a massive area in the Caribbean, folds up into a container, and then it unfurls like a sail, and it tensions, and it captures water and directs water into that. That's the Sail House project. But that project, it started with buying a pier in Borneo, and a disused pier that was made out of ironwood, and then extruded aluminum as the structure, because it kind of comes together like a kit of parts where you don't need skilled labor to assemble it, because you kind of can't make a mistake because everything's square and ID and pre-fit. The whole building was pre-assembled, including electrical and plumbing and furniture and all the finishes, and then disassembled, flat packed into containers, and reassembled on the site. That was a full international project with clients that are British, with engineers that were German, with fabrication in Indonesia, and assembled by Indonesian and Caribbean, workers. So that's a case where, yes, there were some long distances, but then it was all about how do we, if they're going to come long distances anyway, let's ship the most efficient way to get most amount of materials to the site. And that was an interesting exercise.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
An island is a great metaphor for our planet. I mean, it's just the scale. The problem generally is that we look and we think, we could just, where is away? A dump truck comes and it's away. But on an island, it's away, but it's just a little bit closer. On a spaceship, you're very, very acutely aware of what you take, make, and waste. And we've had kind of a cowboy, if you will, mentality, in America, because we've had vast resources and things look infinite, and we're only realizing that there are massive consequences, that things that we think are infinite or can absorb lots of things turns out to have massive consequences. We're the only known living thing in the entire universe, so we're on a spaceship, so
yeah,
we think, okay, this little plastic's not going to matter. And then we end up with the Pacific Gyre that's larger than the state of Texas, that's floating in the ocean, and almost every amount of water on the planet, there's more plastic than plankton, then that has an impact. If we think, we're putting, CO2 into the atmosphere, but I don't really see it. The atmosphere looks huge. There's not going to be a consequence. But then you think, if I ride my bike for 10 minutes, it goes 6 miles. That's the entire thickness of the skin that supports all life on the planet. And incredibly thin. So I think it helps to have that perspective. An island just makes you more aware of what we really all should be aware of. And most of us are not aware of what the consequences are of our actions.
Yeah, it is a good island. It's close. It's, when you can't hide it, right? You can't just dump it over a hill. You are the hill. You're the island. There's nowhere else to go. You're going to wherever you are. I think that greatly influences, right, people that live on the ocean, even, right? And you growing up, right? It's really hard to ignore that when it's right there. And you can see the impact that people are making daily. When you wake up every morning, you see it. But it's a lot harder to ignore it than when you're other places and it's not as visible to you.
Mm-hmm. Yeah, it's a good point. I mean, if you're literally on the water, like on a boat, that would be another really good example of, being acutely aware of your energy use, your waste, what you have. Everything there is, you've got to be very efficient with. So it's very helpful. And I think we're largely disconnected in the kind of technosphere that we live, we're not totally aware of the kind of causality of what we take, what we make, and what we waste. And, it just is out of our sight. But that whole kind of anthropogenic metabolism is a construct. It's a design construct, which is a consumerist construct, which is based on capitalism, which drives the world of everything that we do. So planned and perceived obsolescence is a huge part of that. And it's very, very consumptive. And that includes resources. And that's why we kind of are overshooting and usurping primary resources that the planet carrying capacity has to regenerate. And as we increase our population to almost 9 billion people soon, there's more and more need for these primary resources. And so we're experiencing a force multiplier with climate change as we are going to have more and more competition for resources. That takes this is my 40th year as an architect practicing in sustainability. And I don't think we've ever really achieved sustainability. I think now we're at the resilience imperative. The imperative is that how do we respond to stressors and react to stressors? And how do we even maybe move from resilience to a regenerative or restorative methodology where we undo some of the damage that we've done in the past? And there's an interesting term, one called anti-fragility, which is stressors that actually make a system better, right? So a good example of that would be our muscles, for instance. If we exercise the right amount, those are that's stressors that are making us better. If it's too much stress, it's not good. And if it's too little stress, then that's not good. And when we atrophy, a tree is just like that. If you restrict a tree too much and then it has a stress, it's not going to be resilient enough. But if you allow the tree to kind of keep moving to a certain extent, then you're building up the kind of muscular system or the ligaments of a tree to withstand stress. So I think our architecture, our cities, our infrastructure needs to really think about resilience. And unfortunately, I think it's not based on resilience. These are large central infrastructural systems that have vulnerabilities because they're single large systems, and they're either one point of failure, like let's say the case of Puerto Rico, and you have one hurricane and the entire grid is down, versus a redundant, repetitive, distributed system where it's inherently more resilient. Even if it was a mobile system where it could swarm to, if one side of the island was hit, you could swarm, move things to the other side because they're distributed, nimble systems, not one giant system. And right now, these large infrastructural systems are too slow moving to keep up with the pace of climate change that is happening at a faster rate than even all scientists universally agree is happening.
I think it's an interesting piece because like you said, we try to focus on be sustainable, and I personally agree, we should be looking at regenerative. That's the time for achieving sustainability was a while ago. That was before we started doing real damage. That could have been sustainable. Right now, if we were to just sustain where we're at, it's not. That's the whole problem. So we have to hit that level of regenerating, and then maybe down the road, once we've recovered, then we can talk about sustaining. But at that point, I really think that regenerative is sustainable, because if you're always regenerating resources, land, right, all these things, you're going to be fine. We'll never hit this point again where we're burning more than we have, and not resource managing, right? And it reminds me, when you're talking about resource management, there's a story I heard about, I think it was in the 90s, that the Swedish government got a letter basically from their forestry department saying, hey, your trees are ready for your Navy, because they had placed an order back in the 1800s and they knew it was going to take, we want to build 100 new ships. Great. We're going to plant the trees now. And in about 130 years, we're going to have trees to build those ships. So, obviously technology changed. They didn't need that wood to build ships in the 90s. That's past. But that kind of resource management and planning, that idea, I feel like we've lost in a lot of ways. We're not thinking out that far ahead, which means it's impossible to resource manage if you're only looking 6 months or quarterly. Really, we're looking quarterly. Right. Everything is quarterly at this point.
That's right, because it's all perceived as a resource that we could just, as a resource. That word, in a way, it is one has to think about, because if everything is a resource for us, and the economic system, Paul Hawken writes about this in Natural Capitalism, but we don't even factor in the cost of nature. Right now, if you cut down a forest that quarter and you export it, that quarter is looking good, but the next quarter you have nothing, and then you have a whole cascade of problems from
there's no balance sheet that's like the planet and us. We just pretend. There is. If we deforest everything, there will be no, over here on the Earth side, there will be no forests. But we don't really balance that out and keep. I feel like there's no true reconciliation resource wise.
That's true, and and I think that needs to change in our economic models. And I think it is. I think that there's, there's environmental resource goals of the UN. There's, there are corporate mandates. There's, there's a lot of greenwash but
everywhere.
Yeah. But, I think that there's awareness and concerns, and shareholders are making demands and accountability. And I think that just, look, if you're a doctor, the first step is you diagnose the patient before you know how to treat it. And I think we still have some people that are in denial of the illness, and that it's hard to get treatment when you are being fed, misinformation or believe misinformation or don't want to acknowledge it because it's a diffused, and complex problem. But that we're still somewhat in that first step, unfortunately, with a lot of people, where we could be making more progress if we acknowledge that we've got a sick patient and we need some critical help in a directed way. We're on a path of potentially being a self-terminating civilization. That's, we're just arrogant enough not to think that it could happen to us, but it's happened 6 times on the planet so far. So, it's a question of, how can we survive the journey in time to recorrect? I'm personally optimistic. As negative as all that sounds, and, what science is, the world's greatest problems are the world's greatest opportunities. And that's where I get very, very enthusiastic about innovation. And, I think it just has been that the humankind just hasn't either been aware or hasn't applied technology. But look at where we've evolved. Okay, we had coal, right? And we had, fossil fuel, and then, now we have light that turns with a photovoltaic cell, it turns it into electricity, and, and we could store it in batteries. That's pretty advanced. And, if we look at, as I was saying, if we look at the planet as a site, like we look at what nature has to offer, we've got incredible nuclear energy that's just about the right distance away that we want nuclear energy. And there's more abundant energy that falls on the planet every day than we would need. We just need to use it efficiently. And that's the same for water. And why I got so interested in atmospheric water generation is because it's kind of a planetary system, and there's a lot of water in the air, and we don't have to move water long distances. And water is often unevenly distributed geographically on the planet.
Right, but was it 70% covered in water? So there's a lot of water.
Yeah, the planet is about 76% covered in water, but almost all of that water is salt water and it's not drinkable. We have 0.22% of the planet is fresh water, and of that fresh water, a lot of it's frozen, and it's unavailable in different areas. I mean, it could be groundwater, it could be in other locations, and the hydrologic cycle deposits most of that water back into the ocean if 76% of the surface area is water. And
right.
What's interesting is that, that ocean and all trees and plants are redistributing that water in the form of water vapor back into the atmosphere. And of course, we know that when we see clouds, and then we know that when those clouds get seeded with enough particles that the water turns to droplets, it turns from a vapor to a solid and then binds to that particle and then drips off that particle, and we know it is rain. Those are tied to weather systems that used to be more predictable because those weather systems were tied to ocean temperatures that were pretty predictable, and so the jet stream and the currents of the ocean were somewhat parallel, and now they're meandering, which is why we have these extreme weather events that, are because we have this meandering jet stream. So that means water from rain is totally not predictable anymore, and the past is no longer prologue with weather projection. Can't use the farmer's almanac anymore. The future is totally different. So what is known is that there's about 6 times more water in the form of vapor in the atmosphere than all the rivers on the planet. And so the challenge is, how do you get it? How do you extract that? And how do you extract that efficiently? That's where my fascination with atmospheric water comes into. Because if you could make point of use, right? If you're not taking coal from one state and then shipping it to another and then burning it and then distributing it, 5 states away through, energy lines, losing energy all the way. Right. Or in the case of water, taking water long distance, like in California, where we use 17% of our water budget, of our energy budget, pumping water long distances. So I think point of use, if we take light and that hits our roof and we make the energy and more energy than we even need at that point of use, that's just like we were saying, it's closer, and you have less waste, less energy. So in the same way, what if every building made its own water, or even better, what if it made more water than it needed? Then we could have a more verdant, planet, which would, we'd have more landscape, not less landscape, and that would then contribute more to atmospheric moisture.
Right, because I didn't realize that 17% of California's energy budget is moving water. That's a lot of power just to move water around, which is we're losing one resource just to move around one resource, which is inefficient. You have power loss just to get the power to the pump, and then we use it to move the water.
Right, and the other thing is, we talk about vulnerability. California is dependent upon foreign water and from other states that are growing, rapidly and have demands, and we're at the end of that pipe, so to speak. And those major energy systems are hydrologic systems that are based on dam resources. And those dams, as they get lower and lower, now you've lost not only your water, you've lost your power too.
Those two resources are very, very entwined in how we've set up our system so far, at least.
Yeah, the energy water next is fascinating. And that's the same with atmospheric water, because a lot of systems for atmospheric water require energy to extract the water out of the air. So at that point, then, it's all about which system uses the least amount of energy.
Yeah, that's a whole thing just on its own, figuring out how to do that, but I love the point of use, right? That's where like solar power comes into play, right? Well, I can put solar roofs on, I get power right to my house. I don't have to transport it from some power plant far away. I don't have to buy it from a dam in a different country or a different city, different state. I can actually have it localized to me, which is way more efficient.
Efficient and resilient, right? Because if there's terrorism or climate change or disaster, one point, I mean, there were like 5 states were tied together with one energy grid, and there was one lightning, strike in, Colorado that hit a transfer station and shorted out 5 states. So if there's a problem, you still have energy. If part of, your house goes down, your neighbor still has energy. They're not tied together. That's why a distributed system and these kind of microgrids is even where the utilities are going, because they're realizing it. And of course, like you say, if it's more efficient, then it drives the bottom line of economics for the providers of that energy too.
Yeah, I think efficiency is good for everyone, even though sometimes we don't always go for the most efficient. For whatever reason, it doesn't always seem to make sense, but it does long run. In the long run, efficiency always will win out. It's the whole the hare and the tortoise story.
Right.
Always.
Yeah, I think so. And like taking this full circle back to that from a design perspective, if you could marry those two together, so like I would think arguably a Tesla is a pretty beautiful machine, and people might buy it just based on its aesthetic or the, way in which it drives. It also happens to be, a very efficient resource, and it's better, faster, cheaper. So it doesn't have to be at the expense of design. It could actually inform design.
And that is a very important piece, the design component. And I feel like that's changing. That's definitely, when Tesla came out with their cars, this whole idea of kind of moving sustainability from this hippie, you're out in the country or it's the farmer's market. Nobody really thought it was well designed, but it just, it's sustainable, so I'll do it because it's the only option. And we've really, I think we're in the middle of this shift that I think we need to accelerate, but really applying design to it and going, instead of picking it looks nice or it's sustainable, how about it looks nice and it's sustainable, and really putting our design brains to that and making that happen. And that is part of why I'm more positive. Like, yes, everything sounds pretty negative, but I think at this point where as that happens, more people will want it. And as it just makes it an easier transition over to things that are sustainable and they're beautiful.
Right. And I think you could look at a tree as being pretty beautiful. It's not, if you look at it from a design perspective, it's pretty amazing. I mean, it generates its own energy. It collects water. It sequesters carbon. It's timeless. It doesn't go out of fashion. It has a whole series of ecosystem benefits. And I think you could take almost anything that's in nature, has inherent character and beauty to it. And those are, nature's had billions of years of research and development. Their waste equal food. There's no species that are unemployed. And all right. I mean, it's
true. That's true.
Yeah. We're just kind of out of sync, in some way. And part of that is this kind of creation myth in a way that we have dominion and we're separate from all other species. It's kind of a platonic view of the world that, we're somehow up there and have this we're really a predatory species on the top of a trophic cascade, which is, what's happening now with depredation of species at a faster rate than they can be identified. We're the apex predator at the top of this entire system. And we are different in some ways because we feel like we have a kind of an intellect, and we have this anthropocentric view of our place in the world. And we do have tremendous consequences for our actions. We also have tremendous responsibility, and I think, and ingenuity, and I think mankind could do a lot better in its use of resources. And I think we are moving that way. I think we're generally moving that way. And these things, as I mentioned before, they become force multipliers to be more efficient, when you have less and less resources.
Yeah, agreed. Well, we are getting to the end here. I wanted to, before we wrap up, though, at least talk a little bit about your fund and foundation that you're currently running. So just for everyone listening and watching, kind of you give a rundown on, you mentioned to me, Ray, you're working on the sustainability side primarily, but have you dive into that a little bit more on what both of those organizations do?
Sure. So, I maintain my architecture practice intact. I have SkySource, which, we won the Water Abundance XPRIZE, and pursuing atmospheric water in systems that are exactly that point of use, distributed, kind of community-owned micro utilities and resilience hubs. And resilience kind of became as I mentioned before, really to me, this is the imperative that we need to operate on. And I felt like we have an urgency to act. And part of that urgency is to foster additional innovation in climate technology and water, food, carbon transformation, and energy. So we have a resilience fund, which invests in these emerging technologies. And that we hope to do, well by doing good with those things and help kind of entrepreneurs where other people are not investing so much. And then part of that also is my wife and I have a very small nonprofit called the Resilience Foundation, which funds other nonprofits to achieve the United Nations Sustainable Development Goals. And we use that to fund some of our water projects. So we just funded a water kiosk in a ghetto, massive ghetto, one of the world's largest ghettos, slums outside of Nairobi, Kenya, called Kongawe. They just opened this water kiosk that is distributing water to people that otherwise would have to walk, 6 to 10 kilometers, mainly women that have to walk long distances to carry water that's not necessarily even safe to drink. So that's very meaningful for us. So that's kind of a combination between helping to fund startups in innovative technology space and then to seed nonprofits that are doing things as well as, innovating ourselves.
Amazing. Well, I really appreciate you taking some time. I feel like we could talk for hours on all of this. Yeah. So maybe we'll do another episode, but I really appreciate you taking the time to sit down with me and have this chat and go through your projects and what you're doing. So yeah, thanks for being on my show.
Thank you for having me. Appreciate it. Perfect.
And for anybody that wants to connect with you, what would be the best way to find you?
Oh, sure. Just go to our website at davidhertzarchitect.com or just Google David Hertz Architect and you could find me and email me, right through the website.
Perfect. And for everyone listening, we'll have all those links and everything in the description. We'll make it easy for you to click. And yeah, really appreciate it.
Thank you.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.